Thursday. First thing I want you to do today is to watch that density curve video that was posted under today's work. So go ahead and stop this right here and watch that first. Then when you're back, we're going to be in the 3.1 notes. This is where we left off at density curve. All right, you've just learned that a density curve is a histogram that has been tightened up to form a curve. It's generally bell-shaped in some sort, but it can still be skewed left and right. And the density under that curve is negative, or is positive 1. The area under the curve is always 100% because that's where all the data is. Normal curves, which we'll get to a little bit more next section, are symmetric and bell-shaped. Okay, let's scroll down. All right, these are two histograms that I have attempted to draw the curve around. This first one, the median, is identified for you. It's right where the purple and the green change color. That means 50% of the data is on the left and 50% of the data is on the right. In this green one, we're going to calculate where the median goes. So we have 2 people in this bar, 9, 12, 12, 11, 2, 2. So there are 50 people represented in this chart. So we're going to draw the line where 25, where we have 25 on the left and 25 on the right. So we've got 2 plus 9 is 11, plus 22 is 23. So 2 more people into this bar. So real close there. So that is where your median is. 25 people on the left of the bar, 25 people on the right of the bar. Then when we do mean, this is the balancing point because you've got these people out here on the end of the teeter-totter that are kind of throwing it off. Those outliers move the mean towards the outliers, whereas in the median, they don't. Okay. For these 3 curves, I want you to draw where your mean and your median would go. So let's see, median divides it into 2 equal pieces, something like that. And mean gets pulled by the outliers. So the mean is slightly to the left of the median, slightly to the right of the median, and in this third one where it's uniform, not uniform, symmetric, the mean and the median are exactly the same value. Okay, this is a uniform distribution, meaning all of the values are about the same. The area of this box has to be 1 because it's always 100%. So that is why the curve is equal to 1, because the area is 1. And we have 1 on the base, so we have to have 1 on the height. The mean is the balance point. What is the value of the mean if it's a uniform distribution? Well, it's going to balance right here in the middle, so the mean is going to be 0.5. What is the median? It divides it into 2 equal groups, 50% on the left, 50% on the right, so the median is also 0.5. And then what percent of the observations lie between 0 and 0.4? So you're looking at a box about like that. So our height is still 1, and the base of that would be 0.4. So it's going to be 1 times 0.4, which is 0.4, or 40%. Oh, look. So I wanted you to attempt to draw 2 curves around these, exactly like I did here in red. So we've changed these from histograms into density curves. This one is very uniform-ish, so it's like the box, like in the last example. Okay, for these 2, I want you to identify which line represents the mean and the median. Okay, in the second one, B is going to be your median. It's the one that divides it into 2 equal areas, and A is going to be your mean because it's pulled towards these outliers. But this first one, A is the median, obviously, because it's right in the middle, but which one is the mean? And again, it's going to be A because there are no outliers to pull it. So it's in the symmetric graph, the mean and the median are the same. Okay, so that's it for the 3.1 notes, which means we're done with 3.1 section, which means we're ready for a quiz, which will most likely be Tuesday. Not most likely, it will be Tuesday. 3.1 quiz. Tomorrow for the e-learning day, I do not have a set Google Meet happening. I have a review assignment for you to work on. I will be in office hours from 8 to 11 if you have any questions, and that review assignment is due before class on Monday. I'll be here at 2:15 again today if you need anything.